Hello, this is Mr. Stansbury. I'm going to take you through the notes on trigonometry. Okay, so at the end of this, you should be able to see I can use the rules of trigonometry in 3D space. Okay, so we just have one example for you here. Example 3 for this solid here. Find the center of face CDHG is the first part, and then we're going to find the angle between segment FD and plane BCFG. So here's what we want to do first. CDHG. Here is CDHG. So we want to find the center of this face. That's basically just the midpoint between C and H or G and D. We have the point G there, so let's figure out what D is. So let's write D in there, which is what, out 5, right? And then it's over this far, which is what, 4? It's over 4 and up none. So we got 5, 4, 0 and 0, 4, 3. So we'll just find the midpoint between those two. Midpoint of, and then we've got G and D. That's going to give us, so we're literally just going to add these. Here's our midpoint formula. Add the x's together, divide by 2, y's together, divide by 2, z's together, divide by 2. So we've got 5 plus 0 divided by 2, 4 plus 4 divided by 2, and 0 plus 3 divided by 2. Okay, so 5 plus 0 divided by 2 is 2.5. 4 plus 4 is 8 divided by 2 is 4. And 0 plus 3 is 3 divided by 2 is 1.5. So there is our midpoint. Okay, so we found the center of face CDHG, which we will, let's put that in a different color. Let's put that right about there. Okay, and then part B says find the angle between segment FD and plane BCGF. So we got B, C, G, and F. So that's this top part here. Okay, so we want to find the segment F to D. So there's F, and we'll draw a line to D. And we're going to find basically the angle it makes with this top face here. So easiest way to do that is, since this whole face here is parallel with this one down here, what we want to do is just say, okay, if D goes straight up here to C, I'm just going to basically, let's make this pink triangle here. And we know that this right here is a right angle. Okay, so then we're going to find that angle between FD and the plane. So that's going to be this angle right in here, because there's the angle and that it meets right here with the plane. So where those 2 points, where those 2 parts meet, that's the angle that we're going to find. So let's just redraw this down here to maybe make our life a little bit easier. So here's F, here's C, and here's D. Okay, and then let's see, we know that that's our right angle. We don't know F to C, but we do know that C to D is a distance of, this is at 0, this goes up to 3, so C to D has to be 3. And we don't know what that length is there either, so we're going to want to find what FC is. Okay, so we can do that with the distance formula is just fine, or you could also do a squared plus b squared equals c squared. Since we have the distance formula here, let's just actually use that one. So we're going to find the, for b here, we're going to find the distance from F to C, right? F to C. All right, so F is at 0, 0, 3, and C, we don't have those coordinates yet either, so let's write those down. So that is out 5 over 4, and then up 3. So that's 5, 4, 3, and this is 0, 0, 3. So distance, we're going to do here, I'm going to give us a little bit of room here. D equals square root of, and then we've got the 2 x's. Let's start with, we're going to subtract them. So let's start with this one to make it a little bit nicer for us. We don't have to deal with as many negatives. or none in this case actually. So we go 5 minus 0, because it doesn't matter which point you start with as long as you start with the same point each time. And then plus 4 minus 0. In fact, it doesn't even matter if you start with the same point each time, because when you square each of these, all the negatives are going to go away. Plus, and then we got 3 minus 3. Okay, so distance here is going to be 5 minus 0 squared is going to be 5 squared, which is 25. 4 minus 0 is 4. 4 squared is 16. And then 3 minus 3 is 0. 0 squared is 0. So this distance is going to be 25 plus 16 is what, 41? And then we do the square root of 41. I might just FC, I'm just going to leave it as a square root of 41. And then we can simplify that over here just to see what it looks like, just so you get a real world idea. Square root 41 equals 6.4 basically. 6.4. Okay, and then since we are looking for this angle here, we're just going to use our good old trig ratios, right? Our good old SOHCAHTOA. So from this side here, this is the, let's change to a different color here. This side here is the opposite, and that's the hypotenuse, so that by default makes this the adjacent, right? So we will do opposite and adjacent as tangent, so we do tan theta is going to equal 3 over square root 41. So let's see what we can come up with for that. So we're going to do on here second tangent of, and we can just do this as parentheses. You can also do alpha y equals to make yourself a little fraction here if you want. You don't have to, but it just kind of looks a little nicer. So we do 3 over, and then we're going to just do square root 41 so nothing gets rounded until the very end, right? Oops, let's see, let's get rid of that. I want to go out here, there we go. Close that up so it looks nice and push enter, and it gives us that angle there has got to be 25.1 degrees, so theta equals 25.1 degrees there. Okay, that's all we have for the notes on trigonometry. If you have any further questions, please feel free to ask in class. Thanks.